The babirusa, a wild pig native to the Indonesian islands, is perhaps one of evolution's most baffling and unfortunate creations. At first glance, the babirusa looks like a regular wild pig, until you see its tusks. Male babirusas have upper canine teeth that grow upward through the snout, curve backward, and in some cases continue growing toward the skull. If these tusks aren't worn down naturally or broken during fights, they can penetrate the skull, ultimately piercing the brain and killing the animal. In essence, the babirusa can be fatally impaled by its own teeth. Despite how hazardous these tusks are, they remain a sexually selected trait. Female babirusas appear to prefer males with large, dramatic tusks, unaware that the trait may eventually doom the individual. This means males with dangerous, overgrown tusks continue reproducing and passing on the genetic blueprint for this flawed feature. Unlike other wild pigs, the babirusa isn't well armored. Its skin is relatively soft, and it lacks the usual toughness pigs use for defense. In many ways, it's ill-equipped to live in the wild without additional evolutionary support. This unique case demonstrates how natural selection can sometimes favor traits that are not only impractical, but potentially lethal. The male antechinus, a small marsupial native to Australia, may hold one of the most extreme records in the animal kingdom. It mates so intensely that it dies. During the breeding season, which lasts just 2 to 3 weeks, male antechinuses enter a frantic reproductive frenzy. They compete fiercely for mates, engaging in marathon mating sessions that can last up to 14 hours with multiple females. This behavior is so physiologically taxing that it triggers a fatal collapse of their immune system. To maximize their chances of passing on genes, their bodies flood with stress hormones. These hormones suppress immune function, damage internal organs, cause tissue breakdown, and lead to complete physical deterioration. By the end of the mating season, nearly every male, regardless of age or strength, is dead. What's more astonishing is that this death spiral is biologically programmed. Males are born to live fast, reproduce once, and die. There are no second chances. Unlike females, which can survive to raise their young, males invest everything into a single, suicidal reproductive effort. From an evolutionary standpoint, this strategy ensures genetic diversity and population renewal. But on an individual level, it's catastrophic. The male antechinus is essentially built to self-destruct in the name of reproduction. Imagine having a brain so advanced it ranks you among the smartest creatures on Earth, only to die the moment you try to reproduce. That's the tragic reality of the octopus. The octopus is one of the most intelligent creatures in the animal kingdom. With problem-solving skills rivaling those of some dogs, the octopus can navigate mazes, use tools, and even mimic other marine animals. Some species have even been observed using discarded coconut shells as portable shelters. But for all its brilliance, evolution gave the octopus a remarkably unfair deal. Most octopuses live only 1 to 2 years. This short lifespan severely limits the benefits of their intelligence. Even worse, reproduction is a death sentence. After a female lays tens of thousands of eggs, she dedicates her remaining energy to guarding them, often refusing to eat. By the time the eggs hatch, she is starved and near death. The male doesn't fare better. He dies shortly after mating, sometimes wandering aimlessly until succumbing to predators or natural decay. Newborn octopuses, barely the size of a grain of rice, face an ocean full of predators. Out of tens of thousands, only a few typically survive to adulthood. Physically, octopuses are also extremely vulnerable. They lack shells or any real defensive armor. While they do possess camouflage, ink, and in some cases venom, they remain frequent targets for predators like sharks, sea lions, and dolphins. To compound their misfortune, the advanced brains of octopuses are not protected by long lifespans, social learning, or parental guidance. Evolution created a creature with remarkable intelligence, only to ensure it lives in solitude, faces constant danger, and dies shortly after reproducing. The cheetah is celebrated as the fastest land animal, capable of reaching speeds up to 70 miles per hour. But beneath this impressive title lies a host of evolutionary drawbacks that make the cheetah one of the most vulnerable big cats on Earth. To achieve its incredible speed, the cheetah sacrificed almost everything else. Its slender body, lightweight frame, and semi-retractable claws provide traction and agility, but not strength. This makes cheetahs poor climbers and easy targets for stronger predators like lions and hyenas, who frequently steal their kills. Cheetahs also suffer from extreme genetic uniformity due to a population bottleneck thousands of years ago. As a result, they face high rates of infertility, weak immune systems, and birth defects. Around 70% of cheetah cubs in the wild die before reaching adulthood, often due to predation or lack of maternal care. Their high-speed hunts consume so much energy that after making a kill, cheetahs must rest before eating. This recovery period makes it easier for scavengers to steal their hard-earned meals. Even in captivity, cheetahs struggle. Their extreme sensitivity to stress leads to anxiety disorders so severe that many require emotional support animals to function and reproduce. In short, the cheetah is a marvel of speed, but a casualty of evolutionary imbalance. It traded versatility, resilience, and genetic health for a single trait, and that trade has come at a steep cost. The kiwi, a flightless bird native to New Zealand, is one of evolution's most curious and unfortunate creations. Though it's part of the ratite family, alongside ostriches and emus, the kiwi is significantly smaller, standing around 18 inches tall and weighing under 7 pounds. But its size isn't the only problem. Unlike its larger relatives, the kiwi has no effective means of defense. It cannot fly, run fast, or fend off predators. Its survival depends entirely on the absence of mammalian threats. Unfortunately, with the introduction of cats, dogs, and stoats to New Zealand, kiwi populations have plummeted. Even a few stray cats are enough to push them toward extinction. But the real evolutionary twist lies in their reproduction. Despite being small, the kiwi lays one of the largest eggs in proportion to body size of any bird, about 20% of its own weight. That's equivalent to a human giving birth to a 35-pound baby. The egg is so large, it stretches the kiwi's body, compresses internal organs, and can cause immense physiological strain. Adding to the irony, their ancestors were massive. The closest relative of the kiwi is the extinct elephant bird, which stood 10 feet tall and weighed over 1,000 pounds. Somehow, evolution took that towering legacy and compressed it into one of the most fragile birds alive today. The kiwi is a striking reminder that not every evolutionary path leads to strength or success. Sometimes, it leads to a very vulnerable bird in desperate need of protection. The sloth is often seen as a symbol of relaxation and calm, but behind its slow movements lies a story of evolutionary struggle. Native to Central and South America, sloths live in trees and survive almost entirely on a diet of leaves. While this leafy diet provides nutrients, it is incredibly low in energy, forcing sloths to live at an extremely slow pace just to survive. Their metabolism is so slow that they move only when necessary, often at less than 0.2 miles per hour. Even digestion can take a month. This sluggish lifestyle puts them at risk, especially when they descend from trees, about once a week, to defecate. This trip to the forest floor exposes them to predators, and shockingly, about half of all sloth deaths occur during this vulnerable act. Despite their apparent fragility, sloths have some surprising adaptations. They are excellent swimmers, capable of holding their breath underwater for up to 40 minutes. However, these abilities rarely help in their treetop lives and are often used only during accidental falls. What's most tragic is that sloths descend from a once powerful lineage. Their extinct ancestor, the megatherium, or giant ground sloth, was as large as an elephant and used its massive claws for defense. Modern sloths still have long claws, but they lack the strength or speed to use them effectively. Today's sloth is a quiet remnant of what it once was. Evolution has left it slow, fragile, and nearly defenseless. The male fiddler crab is instantly recognizable by its one oversized claw, a massive eye-catching appendage used to attract females and ward off rivals. At first glance, it might seem like a symbol of evolutionary success, but beneath the surface, it's a costly liability. This large claw serves little functional purpose beyond courtship displays. It's too big and clumsy to help with feeding, meaning the male crab must rely solely on his much smaller claw to eat. As a result, males consume food at half the rate of females, or must spend twice as long foraging. This inefficiency is especially dangerous because fiddler crabs can only feed during low tide. The more time males spend exposed, the greater their risk of being eaten by predators like birds, raccoons, or even larger crabs. Ironically, females continue to prefer males with the biggest claws, believing them to be stronger and more genetically fit. But that preference creates a vicious cycle. Males evolve larger, less practical claws, making them more vulnerable with each generation. So while the claw helps secure mates, it also reduces a male's chances of long-term survival. Evolution has essentially traded utility for attractiveness, favoring a feature that impresses but endangers. The male peacock is one of the most visually stunning creatures on Earth. His iridescent feathers and enormous fan-like tail are a marvel of sexual selection, designed to attract peahens during mating season. But this extraordinary beauty comes at a serious cost. The peacock's tail can make up more than 60% of its body length and is heavy, cumbersome, and difficult to manage. It serves no practical survival function. In fact, it actively hinders the bird. The weight and size of the tail slow the peacock down, reduce its agility, and limit its ability to fly or escape predators quickly. To make matters worse, the bright, colorful display is like a beacon in the wild. While it may catch a female's eye, it also draws attention from predators, especially big cats like tigers. Peacocks with larger, more vibrant tails often fall victim to predation simply because they can't react in time. Despite these dangers, peahens continue to prefer the most extravagant displays. This keeps the trait alive, even though it reduces individual survival. In evolutionary terms, reproductive success outweighs self-preservation. In essence, the male peacock is caught in a biological paradox. The very trait that helps him pass on his genes is the one that puts his life at risk. It's a classic example of sexual selection prioritizing aesthetics over practicality. The Luna moth is one of the most visually captivating insects in North America, with its large lime green wings and long tail streamers that resemble flowing silk. But behind its beauty lies a biological blueprint that offers almost no room for survival. Once the Luna moth reaches adulthood, it enters a final, fleeting phase of life. Adult Luna moths are born without mouths, literally. They have no digestive system and cannot eat. Their sole purpose at this stage is reproduction. From the moment they emerge from their cocoons, the clock is ticking. Most Luna moths live for just 5 to 7 days, surviving only on the energy stored from their time as caterpillars. This means they must find a mate and reproduce quickly. There is no second chance, no nourishment, and no recovery from failure. If weather conditions are poor, or if they cannot locate a partner in time, their lives end without passing on their genes. Their bright coloration and large size also make them vulnerable to predators like bats, despite having no way to escape or defend themselves effectively. In some cases, their wingtails confuse echolocation, but this adaptation is limited. The ocean sunfish, or mola mola, is one of the strangest and most poorly designed fish in the ocean. Weighing up to 2,000 pounds, it is the world's heaviest bony fish. Yet it's shaped like a flattened pancake with fins, resembling a severed fish head. Despite its massive size, the sunfish is an incredibly poor swimmer. Its awkward body and lack of a tail make it slow and clumsy, relying mostly on its dorsal and anal fins for propulsion. As a result, it drifts aimlessly through the ocean, often at the mercy of currents. Its diet consists mainly of jellyfish, which are low in calories. To sustain its bulk, the sunfish must consume huge quantities of this nutrient-poor food daily, making it one of the least energy-efficient feeders in the sea. Sunfish are also incredibly vulnerable. Their slow movements and soft bodies make them easy targets for predators like sharks, sea lions, and orcas. To make matters worse, they host an extraordinary number of parasites, up to 40 species per individual. In fact, they often breach the surface or visit cleaner fish just to rid themselves of infestations. Adding insult to injury, their larvae are just 2.5 millimeters long, so tiny and fragile that survival to adulthood is rare. The tuatara is one of the most fascinating reptiles alive today. Native to New Zealand, it is the only surviving member of an ancient reptilian order that once thrived alongside the dinosaurs over 200 million years ago. In many ways, it is a living fossil, but that status comes with serious evolutionary drawbacks. Tuatara are incredibly slow-growing and long-lived. They can live over 100 years and don't even reach sexual maturity until their late teens or early 20s. While impressive, this slow reproductive cycle is a major disadvantage in a world that's changing faster than they can adapt. Their biggest challenge, however, is climate change. Tuatara have temperature-dependent sex determination, meaning the temperature at which the eggs incubate determines the sex of the offspring. Warmer nests produce more males, and cooler nests produce more females. As global temperatures rise, populations are becoming dangerously male-heavy, threatening future reproduction and survival. Furthermore, tuatara are extremely sensitive to habitat disruption. Introduced predators like rats and cats have devastated their numbers, as the reptiles are slow and defenseless. Despite having survived mass extinctions and dramatic shifts in Earth's ecosystems, tuatara are now at risk, not from prehistoric cataclysms, but from human-caused climate imbalance and invasive species. This ancient reptile, once a symbol of evolutionary resilience, is now fighting against time, temperature, and human impact. The spotted hyena is often misunderstood, but few know that one of its most shocking features lies in its reproductive system. Specifically, the females. Female hyenas have a pseudopenis, a genital structure nearly identical in appearance to the males. It's through this same organ that they must urinate, copulate, and even give birth. This evolutionary quirk has devastating consequences. Giving birth through a narrow, elongated pseudopenis is extraordinarily dangerous. The birth canal must tear open to allow the cubs to pass through, often causing severe trauma. For first-time mothers, the mortality rate is alarmingly high. Many do not survive the process. But the risk isn't just to the mother. About 60% of hyena cubs suffocate during birth, unable to make it through the restrictive passageway. Despite these life-threatening risks, this anatomical feature persists. It's believed to be linked to the hyena's complex social structure, where females dominate and elevated testosterone levels contribute to both physical power and genital masculinization. However, this evolutionary trade-off prioritizes dominance over reproductive safety. Hyenas are strong, intelligent, and socially advanced animals. Yet one of the most essential functions of life, birth, remains an extreme hazard due to a design nature has yet to fix.